Can I please call XN Skosana to come and do the following presentation for us. An empirical framework for virtual assembly training in learning factories. The floor is yours, sir. 2 minutes.
Good morning, everyone. My name has already been said. I thank Ms. Pepe for asking the question if you are awake, because I'm looking forward to your feedback. I don't want to listen to myself more. Okay, so this is what the presentation is about. I want to emphasize. Okay, so the study is based on a learning factory concept where industry meets academia. So the learning factory concept is where students innovate and then industry comes and gets the ideas there. This was initially proposed by my HESO. So my area is virtual reality. The problem we are solving is that we want to reduce training time and error rates. So there's been many studies that show that this is possible. But then this differs across different contexts, and also as technology improves, this might change also. So the aim of this study is to develop a virtual reality environment in the learning factory, and in so doing we want to guide other learning factories who seek to do the same. So to achieve this, we formulated 4 objectives, and the first is we must know how to measure the effectiveness of VR, and then secondly, we must develop this VR using an agile methodology, and then we will evaluate the effectiveness of the solution, and then lastly, we will retrospect on what we have done, and then that will be the framework. So to start with the literature review, we started with the literature review wherein we downloaded 129 papers, 152 papers, but then some of them we couldn't access them, and then we read 129 abstracts, and then ended up including 57 of them. Currently, I need to review 49. So here we are looking to determine the effectiveness of VR and the challenges that come with it. So we are looking at journals and conference papers only, and experiments. So we are using the design science methodology, which was borrowed from ICT. So we did a literature review and then an experimental design so we can define the problem. The problem, if it was in industry, we wouldn't have to set up we wouldn't have to have an experimental setup, which is the future work where we want to take this technology now to industry with the real operator users. And then we want to develop 3 prototypes on desktop, on head-mounted display, and also on touch interfaces. We're going to use human-centered design and the agile methodology, and then we'll evaluate the solution using heuristic evaluation, and then also using a set of participants, 34 students who are doing industrial engineering. And then we're going to compare the findings and then conclude. So we are developing a system. So in this system, I feel wrong to say this is my research work, because so many people have role-played here, and these are the people who have role-played, and I thank them a lot. Mutari has been doing the software, designing it on Unreal. So we're using Unreal, SolidWorks, Blender, and then for our equipment, we're using the HTC Vive Pro. So our workflow is we have an instructional designer who specifies how the environment should look like, and that's myself, and then they give it to the assets that they need. They give to a CAD designer, Modiba is one of them, and then they construct the models, and then they give them to the software engineers, Johnny also being one of them, for developing the desktop, and then Mutari developing the head-mounted displays. So we're using...
No, they are doing well. Oh.
So what we did first was we did a hierarchical task analysis where we break down the task or the job of, so our case study is welding jigs, the welding jigs that were delivered to Kivela. So what's next now is we want to train operators how to use these jigs using VR. So the first thing we did was to do a HTA where we break down the whole work into steps. And then after that, we did requirements gathering. So some of these questions are answered in the HTA, like where will these parts be positioned, what tools are needed, what conditions, etc. and etc. And then, okay, well, there's a lot of animation here. So ultimately, we ended up with 9 use cases where we say the person should be able to log in and register, select a part to assemble, select a training mode, walk to a workstation, sequence parts into a jig, and then clamp the parts and rotate the jig and weld. And then, and then we designed a system architecture where we're looking at particularly head-mounted displays consisting of base stations which track the user as they move, because this is a huge advantage of VR. The fact that you can maintain your natural motions whilst doing an operation. And then going into detail now, it's a pity you can't see this, we developed interfaces for allowing all those things which are the use cases, the training mode. A person can say whether I want to learn or be assessed, and then when the person chooses learning, there are instructions, and then the person can log in, and then it captures the person's details, and then we can track the operator as they are improving in their training. And then I would have loved to emphasize that, but you can't see. And then the operational sequence diagram, now it explains what you want the system to do. The first thing you want to do, you want the learner to log in, and then what should the interface do? It should verify those details, and then the database gives feedback. If the details are there, what happens? If the details aren't there, it requests the user to register. If the details are there, then it requests the user to select a part which they want. So so we've done all this documentation, but Agile says less documentation and more work, and this is true because I get frustrated. I compile all these nice documents, and then I give them to Mutari, and then they don't read them. And then they come and they ask me, what should I do? And I say, I wrote it there. Yeah, well, they just don't like to read. So Agile does discourage excessive documentation. Prototype implementation. So again, we are in the learning phase. It's nice when we plan, we say, this is when we're going to start, this is where we're going to end. But then we never, meet those deadlines because there's a lot of learning that needs to happen. And then this makes the project planning a bit, tricky. Things would have been a lot quicker if we were not learning. So this is what Bumutari have to deal with. And my standpoint is the work we are doing is enough to, we as industrial engineers can focus on the design and evaluation of a system, and then we can have some other engineers focusing on the building of the system. Because, for instance, this visual scripting, I feel so wrong to report on this because I don't do it. It's Bomutari who do it. So this is enough to be, we're engineering a whole system. It can produce another degree. So part of evaluation is that in this experiment, I skipped heuristic evaluation because in heuristic evaluation, you have you call the experts to come and evaluate the system and tick certain boxes to say, does the user feel dizzy? Does the environment look realistic? They tick all those boxes. So we will still do that, but under the experimental design, what we do is we have participants and then we split them. We say some will be trained using desktop, some will be trained using touchscreen, and then others using head-mounted displays. And then in the end, we give them the actual assembly, and then we compare their performance. So what I maybe here didn't speak about is another secondary contribution is how we're gonna analyze the data. So we're gonna analyze the data using a systematic human error reduction approach, which looks at reducing the errors that the user does virtually, and as in like if the user is not able to press the right button. So that differs. If the user cannot press a button or does not know how to use our system, it does not mean they don't know how to complete the task. But it means they just don't know how to use our hardware. So using this Sherpa, we are going to compare we're going to use Sherpa so that we can know where we need to improve our system. So it's a pity this video now doesn't play. So we managed to get to this level where we designed 3 workstations, and then this is how the workstations look like. So far, the user is able to grab a part and then place it using the snap to slot function. Yeah, sorry. Okay, yeah, great. So this is what I want to emphasize. So looking at my project, our project, with these 3 stakeholders, this is their area. What I have noted that could be their area of improvement. For the chair, when we had this project working with Naledi 3D, we could have enforced skill transfer better because they just gave us a software but they didn't give us skill. And then we need to have more ICT graduates. We need to have them on board. Yes, I understand that these funds are for industrial engineering and so forth, but industrial engineering at this point needs ICT. And then Gibela Rail Consortium, access to information, because we want to develop a solution that will have high impact to the industry, not just a solution that just proves that it can be done. We want to know where are your pain points. And then as a researcher myself, only now I see that what we should actually do is we should develop short learning programs. And that's how we are going to sustain ourselves, because we suffer from turnover. People leave because they're not well incented. But now we only recently came up with a strategy to say we need to develop short learning programs, but then still, even there, we would need someone from ICT to come, and we could focus on project management, and then they focus on the programming side, and then that's how we retain the skill. And then I was slow to finalize the business plan, and this is how we can get funding. I blame myself there, and then I was not loud about these challenges. And I must say, like we got here, we have Omutari, we have Mudiba. This team, it was unplanned, but they, I was engaging Tulu, told Tulu that we need skill, and then it just so happened that we got funding from Sakra. So had it not been for that funding, we wouldn't have been where we are right now. So I don't know. I just have to say it's God. I don't know who else to say it is, because things just worked out and we didn't make it work. Thank you.